Welcome to the 45 session of LMS. Program is for BSc Subject Mathematics for 5th semester. The title of the paper is Numerical Analysis. In the numerical analysis, we are going to see the topic called finite difference, in which today we are going to solve the problems on factorial notation. We go for the recap first. In the previous session, we defined the factorial notation and represent a polynomial in factorial notation. In this session, at the end of this session, we can able to solve the problems related to the factorial notation. So example, if we take a first example, express the f of x, that is they are given a polynomial in factorial notation, and also find its successive difference, that is we have to find its difference also. So for that the solution will start. So let f of x be the given, that is here it is f of x is equals to 2x cube minus 3x square plus 3x minus 10. So now I will represent this in the form of a factorial notation in general form, that is, as we can see, the degrees of the polynomial is in ascending order. So I will write it as it is, that is a, here you can see here ax cube factorial plus b x factorial 2 plus c x factorial 1 plus d. Here we are going to take all as a plus, but its degree is 3, 2, 1, 0. So I have taken it as it is with a, b, c, d. I have to find this a, b, c, d by dividing this f of x by x, x minus 1, x minus 2, x minus 3, right, successively, as there are only 3 degrees is there. Equation is of 3 degree, third degree. So I will divide it by x, x minus 1, x minus 2, x minus 3 successively by using the synthetic division method. Now you can see it here. I have taken the coefficients. Here the coefficient of x cube is 2, x square is minus 3, x is 1, and minus 10 is the constant. So you can see it here, same I have taken it 2, minus 3, 3, minus 10. So I have to divide it by x is equals to 0, x minus 1 is equals to x minus 1, x minus 2, x minus 3. First x is equals to 0. If you take x minus 1 secondly, then it will become x is equals to 1. X minus 2 means x is equals to 2. X minus 3 means x is equals to 3. Here we are told that we have to divide successively by these terms. That means this one, that is x is equals to 0. This one, x is equals to 1, it will becomes this one. X is equals to 2, it will becomes, this becomes x is equals to 3. Now taken by synthetic division, x is equals to 0. So coefficients have been written here. So this is 2, 0, 2 into 0, 0. So if you simplify this, it will be minus 3. 0 into minus 3, 0. If you add this 3, 3 into 0, 0. So if you simplify this, it will be minus 10. Right? Now next I will take x is equals to 1. X is equals to 1, I will take it. Now 2 plus 0 is 2. 2 into 1s are 2. So if you subtract this, it will be minus 1. Minus 1 into 1, minus 1. I wrote it here. If you simplify this, it will be 2. Right? Now I will leave the last values always. As we know that synthetic division method, I will put this line here. Right? Now I will take this term 2. 2 plus 0 is 2. 2 2s are 4. I have to take, subtract this. 4 minus 1 is 3. I have taken 3. Right? Now again I will do 0. 2 plus 0 is 2. Right? X is equals to 3. You cannot multiply further, so I will keep this here. It will end the synthetic division method here. Now I will write this value, whatever the remainder, last remainder will be there, that is A, and this is B remainder, second remainder will be B, third remainder will be C, and the last remainder will be D. If it will increases, we have to take A, B, C, D, E like this. If it increases remainders, okay, fine. We have got now the value of A, B, C and D values. Now I will substitute this A, B, C, D value over here, right? Now I have substituted here, you can see it here, that is f of x is equals to 2. We have got 2, 3, 2 minus 10. 2, 3, 2 minus 10, right? We have substituted it here. In the factorial, now our equation has been converted into factorial notation. This is the required equation in the factorial notation. Now I have to go for the forward differences. That is, differences I have to find for this one. Delta of f of x is equals to, so we know that as we are told in the successive difference is nothing but it is just like a differentiation for the factorial notation. So you can go it. So it is nothing but 2 into x factorial. It's differentiation, that just like a differentiation it is. Okay. So x cube differentiation is 3x square. You can see it here. We have done that. 3 2 is 6, 6x factors. Similarly for this one, 3 2 is 6, x factors 1. If it is 2x factorial 0, right? Similarly, we have simplified it here. Now second forward difference it is, you can see it here, that is, it is just like a differentiation. Okay, so 6 2 is 12, x factors 1, 1 into 6 6, x factors 0, right? So next, finally I can say that this is a second difference equation. Now it is delta cube, that is again I am applying. So it is x factors 1, which if you apply the difference, then it will be 12. So we have applied successively and we have got finally, that is delta cube. Okay, successive difference is delta cube of f of x we have got. In this way we have to solve the problems. So now you go for the inverse forward difference operator. What is that? If delta of f of x is equals to g of x, here remember this is delta of f of x is equals to g of f, then I can say that f of x is nothing but a delta inverse of g of x. The symbol this is there, no, that is delta inverse 1 is called the inverse forward operator, right friends? So the symbol is called the inverse forward difference operator. Now we have a one note is there, that is, if you apply for this, that is delta inverse of x factorial n is given by x to the power of n plus 1 factorial divided by n plus 1, right? This is divided by n plus 1. Here it should be delta inverse of x factorial 1, x factorial n is equals to x factorial n plus 1 divided by n plus 1 plus c, where c is a constant. Okay, so we will solve an example on this so that we can understand in better way. Find a polynomial. By using that formula we are going to find a polynomial. You can see it here. Find a polynomial whose first difference is g of x, that is 9x square plus 11x plus 5. That is, they are given a first difference there, that is, they are given a delta of f of x. Remember this, right? They given a delta of f of x here, right? They are named it as a g of x, right? Let f of x be a polynomial such that delta of f of x is equals to this one. We have to find a polynomial. Now they have given a first forward difference, you can see it here, right? We have to find polynomial. So they are given g of x, they are saying. So let us represent g of x in factorial notation. So that is, they are given g of x is this one, 9x square plus 11x plus 5. So if you write this in factorial, how we can write it? That is, A x factors 2, B x factors 1 plus C. Right? We are writing this in factorial notation. Now I will apply synthetic division method. You can see it here as x is equals 0, 1, 2 and simplify this. This is 9. 9 zeros is 0. If you add 11, 11 into 0, 0, 5. We have got one remainder here. Right? Similarly, we will go for x is equals to 1. Then 0, 9 plus 0, 1. 9 plus 0 is 9. 9 into 1 is 9. It is 11 plus 9, 20. This is second remainder we have got. Now 0, 9 plus 0, 9. So again I cannot go ahead forward. So this is my last remainder, third remainder. Now from here I have to label it. Here first remainder is A, this is B and this is C. Right? So now I will convert that equation to the factorial notation. So it is 9, 9, 25. You can see it here 9, 25 with x factor 2, x factor 1 plus 5. Right? This is my g of x. I know that. This is my g of x, this one, and this is my delta of f of x. You have wrote that. That is delta of f of x is nothing but an g of x. So that is delta of f of x is this one. So g of x, therefore I can say that it is 9x factors 2 plus 20x factors 1 plus 5. Right, friends? So now, as per note, I can say that if you bring this delta this side, it will become the inverse operator now. So f of x is equals to delta inverse of this factorial function. Right? So what is this inverse? It is nothing but an reverse of delta. It is nothing but an integration format. Right? So now if you take this, what is the integration of x square? I can say x to the power of n plus 1 divided by n plus 1. As we have note, we have seen. Now we have seen that note. So as per that, 9 I have kept as is. X factor 2 is x to the power of n plus 1 factorial divided by n plus 1. According to the formula, note formula. Right? We have wrote that. Similarly for this one, 20 into x factors 1. X factors 2 plus 1 in 1 plus 1 it will becomes 2 divided by 1 plus 1 it will become 2, right? 5 as it is, so it is x factors 1 plus k, right? So by the definition, what is the definition? X factors definition, what does it says? Constant I have 3. Now I can simplify. 3 ones are 3 3s are 9, 2 ones are 2 10s are, right? So you can see it 3, 10 and 5 is there. Now x factor, what is this x factor formula? It is x into x minus 1 into x minus 2. That one by definition of the first definition of the factors. This one we will apply it here. It is x into x minus 1 into x minus 2. Now what is this second one is 2 factors. So 2 factors is x into x minus 1. Last one only x we have kept plus k. If you simplify this, multiply this, all the simplification if you do means you will get 3x cube plus x square plus x plus k, which is the required polynomial, right? So by using that inverse factors, that is the inverse formula, we have found a polynomial, right? So at the same time, some of the reference books are here for BSc 6th semester, G.K. Ranganathan, Dr. Mantesh Swami, by Jairam, Prabhakar, Shantakumar, Tunadarshan. So these are all some of the textbooks for you. So thank you friends.